clickmyproject.com. Let we discuss about the process rank-based decision fusion for 3D shape-based face recognition. Let us see the abstract of the process rank-based fusion decision for 3D shape-based face recognition. Face recognition has most interesting and important research fields in all the processes. The identification of the persons is more important in automatic recognition systems and surveillance systems. In this process, the face based recognition is employed using the identification of the patch based separation and the extraction of the features based on a local gradient pattern and ICP registration of the input images. The faces regions are matched by calculation of the equivalent distance between the test image features and the trained sequences. The extracted features were then measured, and based on that the identification of the faces were employed. So in this process the 3D modeling of the face regions were helpful in producing the annotation points from the images. So while collecting the dataset, we extract the annotation points also for the input images that we are using, and based on those annotation points the regions were obtained and the 3D viewing of the input images were done. Only we view the images in 3D format, and after that the patch separation is employed and the features were extracted, and the recognition is done by calculating the difference between the features based on the equivalent distance measurement. The overall performances of the processes were measured in terms of accuracy and error rate. The proposed methodologies shows improved performances compared to the registration processes and other feature extraction methodologies. Compared to using local gradient pattern alone or using ICP registration alone, the combination of the ICP and the local gradient pattern improves the overall performances of the process. Let me see the flow of the process. The input images were obtained from the datasets. While collecting the input images, the datasets were identified to contain the face annotation points of the input images in both 2D and 3D coefficients. So, the input images along with the face annotation points were extracted from the dataset. After the collection of the face images and the annotation points, the recognition process is started. First, the input images were recognized in terms of 3D viewing of the input images. After that, the face parts were separated, and based on the separation of the face parts, in each face parts the features were extracted. Here, the regions that were detected as face parts were eye pairs, left eye pair, right eye pair, like that. After the detection of the face parts, the registration of the face parts features were employed based on the iterative closest point features. Here, the annotation points that we are extracting were registered by the identification of the ICP features that were extracted. Then, for each face parts, the local gradient pattern features were extracted. The local gradient pattern features identifies the textures in the images that we have given. The extracted texture coefficients and the registered points were used as the features for the process. After combining these two features, the process is repeated for all the images in the datasets, and the distance between them were measured in terms of the equivalent distance. The test image feature and the features of all the images in the datasets were subtracted and the distance is measured. The image that contains the minimum distance compared to the input image were obtained as the recognized image. Finally, the performance of the process is measured, which is done in terms of accuracy and error rate. Let us see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the process getting started. So when you click run file, the process getting started. At first the input image will be displayed so that we can select any one of them which is presented in there. So select any one of the files in the dataset and click on open. So while we select open, the images were read, and along with that the points, 3D points and the 2D landmark points were also read, and they were displayed here. So this is the input images, and this is the 3D display for the input images, original input images along with the landmark points, and the 3D landmark points will be displayed in the projections of the 3D planes. So these images were that based on that the 3D maskings were obtained, which is based on the landmark points extracted from available, which is presently or readily available in the datasets. So these are the face parts obtained. The obtained face parts, for each obtained face parts the parameters were estimated. So at first so this is the final ICP registration processes. So the obtained image points extracted were registered, and this is the feature values, and this is the overall accuracy and error rate, and this is the LBP image that we have obtained. uh, so this is the first image that we got, that is the original image with the identified landmark points. Then this is the 3D images masks of the input images that is obtained by projecting the input images in the 3D viewing points. Then after that, this is all the 3D landmark points which is estimated for the identification of these parameters. After that, so these are all the separated feature face paths in each of the cases. So totally we split the face paths into some 4 different regions, and based on that the landmark points were used for the predictions of the regions. This is the final ICP transformations which is obtained by registering the 3D phase points, which is presented, and based on that their rate is measured. This is the final LGP images. The gradient patterns were obtained from the images. These textures based on the features were extracted, and the extracted values were combined with the registered points so that we get the final feature values, and based on that the recognition is done. So this is the input test image, and this is the recognized image. So the persons were identified, so the test image is recognized with second person, like that the message is gone. This is the overall accuracy and the error rate of the processes that we have obtained. So as we can see, overall accuracy will be near 96%, and the overall error rate will be near 3 point something percentages, like that. Hence we have recognized the face images which is presented in the databases, and based on that the face recognition and the is done, and the accuracy and error rate of the processes were compared, and the results were got. Thank you.